Sweet spots in unconventionals are increasingly rare. It is important that an operator gets the most out of a play without leaving hydrocarbons behind. Accurate evaluation of the frac job can maximize production in the short and long term. However, analysis of the various diagnostics means ingesting enormous amounts of data. Matters are compounded as multiple service companies provide different data types from multiple sources that all require synchronizing to a common reference in both space and time. And that's where Orchid comes in. As a single platform to upload completion and diagnostics data, operators can make sure that money spent on analysis goes where it matters most, on value discovery. When the relationships between multiple parameters are loaded and visualized, outputs from different analyses can begin to make real sense. The surface equipment used in fracking is complex enough, but this is nothing compared to what is happening subsurface. By using different diagnostic types from pressure, temperature, microseismic, DAS and DTS, and tracer data, operators can understand the intricate complexity and geometry of the well and reservoir from which they are producing. Understanding the fracture distribution created downhole demands the right metrology. One relatively easy way to understand interactions between wells is to record pressure and temperature time series whilst fracturing. When water and sand are injected into a treatment well, the stress field that is generated can be recorded on a nearby well by downhole or surface gauges. Orchid makes looking into this data in detail quick, simple, and painless. Being able to extract the first derivative seamlessly on an interactive plot or analyze the primary data, the user can determine the volume to first response, define the fracture-driven interaction type and magnitude, and assess the severity of those interactions. With Orchid, VFR, magnitude, and the type of interaction can be clearly represented in 2 and 3D views along the well bore. Supporting workflows and data tables allow completion, reservoir, and G&G teams to interact on a common collaborative platform to understand the impact of well placement, completion design, and operating procedures. To understand how efficient a specific completion design is at creating a fracture, one common diagnostic used is chemical tracers. Water, gas, or oil-based, Orchid can represent the chemicals injected and recovered in 3D views, data tables, and histograms to assess reservoir conditions and optimize production. Another helpful diagnostic typically used during hydraulic fracturing operations is microseismic data. Events can provide a look into how the fracture system is developing. Orchid can play these events in 2 and 3D views to understand the impact on completion and geology in space and time. Through studies, Orchid can classify events based on the depth distribution or distance-time relationships to extract a constrained microseismic-derived primary fracture geometry. More recent, easier access to fiber data allows operators to add another detailed level of definition to their fracture mapping. Smartly creating a continuous data set from any type of input data format, Orchid displays waterfall plots that are easily navigable and can be interpreted to pick or QC frac hits, fracture, or stage corridors. Discovering how many fractures intersect the fiber wellbore, the fracture azimuth, as well as cluster efficiency, are all important results that can be derived from DAS and or DTS data. Finally, all these diagnostics can be combined and interpreted jointly through data frames and visualization tools to offer a fully constrained fracture geometry for seamless export to Topaz RTA numerical models. The real physics workflow from frac to forecast is complete.